The YSI 650 MDS display unit. The YSI 650 MDS display unit is an instrument that allows the user to tell the sonde what parameters to measure and how often to make water quality measurements when the sonde is deployed in water. The display unit is also used during calibration of the sonde. Installing batteries in the 650 display unit. The 650 display unit requires 4 C-type batteries. Change the batteries in a dry environment only. Carry spare batteries. Step 1. Loosen the 4 screws on the battery compartment lid using a screwdriver and remove the lid completely. Notice the 4 small holes on the lid. Barometric pressure is read through these 4 holes. Never cover them with tape or stickers or push anything through these holes, for example, pins. Step 2. Insert the batteries between the clips, being sure that the orientation is correct. A foam pad on the back of the lid will help to hold the batteries in place when the lid is put back on. Step 3. Reinstall the battery lid and tighten the screws. Do not over-tighten the screws. Installing batteries in the sonde. Batteries provide the power for the sonde to collect and store data when it is deployed in the water. Make sure that the sonde contains fresh enough batteries before it is deployed or no data will be collected. This sonde takes 8 C-type alkaline batteries. Carry spare batteries with you. Step 1. Using the hex tool, loosen the battery lid screws. Step 2. Remove the lid. Install the batteries as shown on the guide. Ensure that they have the proper orientation. Step 3. Before replacing the lid, it is important to ensure that the orange O-ring is seated completely within the groove on the underside of the lid. Press around its edges to make sure it is not popping out of the groove anywhere along its length. Small retaining tabs along the O-ring help keep it inside the groove. There is a detailed description of how to properly seat this orange O-ring on pages 219 to 220 of the YSI instruction manual. Do not lubricate the orange O-ring, but make sure it is clean. Step 4. Make sure that the black O-rings that encircle the lid are completely clean. No dirt should be present on or under any of these O-rings. Apply a small amount of Krytox to the black O-rings so that they are shiny. Do not over-lubricate them. Step 5. Put the lid back on the battery compartment in the orientation shown. Push down to make sure it is seated properly. Tighten the screws until snug, but do not over-tighten the screws. Remove batteries from the sonde when not in use, for example, for long-term storage. The battery compartment of this sonde has a lid with a round pressure release safety valve. In the highly unlikely event that the batteries should malfunction and degas, this valve will release any pressure building up in the battery compartment. If the valve ever opens, the battery compartment lid must be replaced with a new one from the manufacturer before the sonde can be used again. Installing sensors. To prepare the sonde for calibration and data collection, you will need to install probes, also called sensors, into the ports on the sonde bulkhead. When initially received from the manufacturer, there are screw-in plugs in the ports to protect the port connections from damage. Do not discard these plugs. Save all plugs for future use. During use of the sonde, plugs must be present in any port where a sensor is not installed. The electronics inside the sonde are easily damaged by water. It is very important that water and other solutions are never allowed to enter the PVC body of the sonde. Ensure that all sensors and plugs are properly installed at all times that the sonde is in contact with solutions. Step 1. Remove plugs from the ports. Plugs are removed by inserting the long end of the installation tool into the holes in the plug tops and gently unscrewing. The installation tool can be found in the maintenance kit. Always remove plugs and sensors from the sonde with that end of the sonde pointed towards the ground or floor. If there is water present on the sensors or plugs, removing them as they are pointed down will allow water to drain away and prevent any flow of water up into the electrical connections inside the ports. Step 2. Installing sensors. This sonde has two different types of ports capable of accepting sensors. The first type are called optical ports. There are 4 optical ports on this sonde, labeled O, B, C, and T. O port is for the optical dissolved oxygen sensor, model 6150. C port is for the optical chlorophyll sensor, model 6136. T is for the optical turbidity sensor, model 6025. B port currently has no optical sensor, so it is blank for now. There are also regular ports. There are 2 of these. They are not labeled, but they are very different. The 6-pin port is for temperature conductivity sensor, model 6560. The 4-pin port is for the pH oxidation reduction potential sensor, model 6569. Before inserting any sensor, ensure that the port is free of moisture. Use a clean, lint-free cloth to dry if necessary. Installing optical sensors. Install the optical sensors before you install the regular sensors. Recall that our 3 optical sensors are chlorophyll, dissolved oxygen, and turbidity. B port will not contain a sensor, so we need to reinstall the plug. As an example of how to install an optical sensor, we will install the optical dissolved oxygen sensor. Ensure that the O-ring on the sensor is completely clean of dirt. Dirt will allow a path for water to enter the electronics of the sonde when it is deployed. Apply a very light sheen of Krytox to the clean O-ring. Remove the sensor cap. Insert the sensor into the appropriate port, in this case O, and gently rotate until the pins of the connector are aligned. Slowly finger tighten the nut down towards the bulkhead. During this step, be careful not to cross-thread the nuts. If you meet resistance while finger tightening, stop, back out, and begin the process again. Finish tightening using the short end of the installation tool so that the seal is waterproof. Do not over-tighten. When tightened properly, it is normal for there to still be a 1 to 2 millimeter gap between the nut of the optical sensor and the body of the bulkhead. Install the optical chlorophyll and optical turbidity sensors in the same manner. Installing regular sensors. Install regular sensors after the optical sensors. As an example of how to insert a regular sensor, we will install the conductivity and temperature sensor. Ensure that the O-ring on the sensor you are inserting is completely clean of dirt. Apply a very light sheen of Krytox to the clean O-ring. Insert the sensor into the appropriate port, in this case the 6-pin port, and gently rotate until the pins of the connectors are aligned. Push the sensor inward so that it seats in the port snugly. Slowly finger tighten the nut down toward the bulkhead. During this step, be careful not to cross-thread the nut. If you meet resistance while finger tightening, stop, back out, and begin the process again. Use the long end of the installation tool to tighten the nut an additional quarter turn until snug. Do not over-tighten. When tightened properly, there should be no space between the nut of the regular sensor and the body of the bulkhead. As another example of how to insert a regular sensor, we will now insert the pH and oxidation reduction potential probe. For this procedure, you will need to put on protective gloves. Remove the cap from the electronics end of the pH ORP sensor. Ensure that the O-ring on the sensor is completely clean of dirt. Apply a very light sheen of Krytox to the clean O-ring. Remove the sensor from the electrolyte solution by unscrewing the cap. Remove the cap and O-ring. Close the bottle with the second cap. Insert the sensor into the appropriate port, in this case the 4-pin port, and gently rotate until the pins of the connectors are aligned. Push the sensor inward so that it seats in the port snugly. Slowly finger tighten the nut down toward the bulkhead. During this step, be careful not to cross-thread the nut. If you meet resistance while finger tightening, stop, back out, and begin the process again. Use the long end of the installation tool to tighten the nut an additional quarter turn until snug. Do not over-tighten. When tightened properly, there should be no space between the nut of the regular sensor and the body of the bulkhead. Installing the probe guard or calibration cup. The probe guard protects the sensors during deployment and allows water to flow over the sensors. Once all the probes are correctly installed and calibrated, screw the guard onto the sonde by aligning the threads and turning clockwise until the probe guard is securely attached. The calibration cup is used during sensor calibration and for long-term storage when the sonde is not in use. It is a solid plastic cup. The calibration cup is installed in exactly the same way as the probe guard. Connecting the sonde to the YSI 650 display unit. It is extremely important to keep water out of the electrical connections between the display, field cable, and sonde. One tip is to connect the instruments in dry environments only, for example, inside your vehicle at your field site if it is raining, not outdoors. To connect the sonde to the YSI 650 display unit, you will need the sonde, the 650 display unit, and the field cable. Step 1. Remove the waterproof cap from the sonde connector. Do not discard this cap. You will need this cap for later deployment and long-term storage. Step 2. Connect the field cable to the sonde connector. There is a guide inside the connection that ensures that the pins are properly lined up. Rotate the cable gently until the guide engages. Step 3. Tighten the connector by turning clockwise. When connected properly, only 2 threads should be visible. Step 4. Attach the strain relief connector to the metal handle and close the connector's opening. Step 5. At its other end, the field cable plugs directly into the 650 display module using an 8-pin connector. Line up the guides and pins inside the connector. Be careful not to cross-thread. Gently turn the nut clockwise until it clicks to lock the connector in place. Attach the second strain relief connector to the display unit. Dissolved oxygen calibration. Before dissolved oxygen calibration, make sure that ODO sat%L and ODO milligrams per liter are turned on under the Sonde menu report screen. Step 1. Add a few milliliters of deionized water to the calibration cup. Step 2. Screw the calibration cup onto the sonde, only engaging a few threads so air can diffuse into the calibration cup. Do not tighten the cup completely onto the sonde. Be sure there are no water droplets on the dissolved oxygen sensor or on the temperature sensor. Ensure that these sensors are not submerged in water. Step 3. From the Sonde 650 menu, select Calibrate and press Enter. Step 4. Select Optic O dissolved oxy and press Enter. Step 5. select ODO SAT percentage, press Enter. Step 6. Select 1 point, press Enter. Step 7. Enter the barometric pressure reading at the bottom right hand of the screen and press Enter. Record the barometric pressure reading on the calibration sheet. Wait 5 to 10 minutes to allow the readings to stabilize. Step 8. After allowing the dissolved oxygen readings to stabilize, record the pre-calibration value in milligrams per liters and in percent local on the calibration worksheet. Step 9. Highlight Calibrate and press Enter to calibrate the dissolved oxygen sensor to 100%. Record the post-calibration dissolved oxygen in milligrams per liter and percent L local on the calibration worksheet. Press Enter to continue. Press Escape until you return to the main menu. Locate the ODO gain value under Sonde menu, Advanced, Enter. Cal constants, Enter. Record the ODO gain value on your calibration worksheet. This value should fall between 0.75 and 1.25. If this value does not meet this criteria, the dissolved oxygen disc is probably old and in need of replacement. Press Escape to return to the main menu. Step 12. Remove and empty the calibration cup. The calibration for dissolved oxygen is complete. Depth calibration. Step 1. Make certain the depth sensor is in air and not immersed in any solution. Step 2. From the Sonde menu, select Calibrate and press Enter. Step 3. Select Pressure ABS and press Enter. Step 4. Input 0.00 and press Enter. Step 5. Wait 30 seconds or so until the readings have stabilized. Record the pre-calibration depth reading on the calibration sheet. Step 6. Press Enter to confirm the calibration. Step 7. Record the post-calibration depth reading on the calibration sheet. Step 8. Press Enter to continue, and then Escape to return to the main menu. Depth calibration is now complete. Temperature and conductivity calibration. Step 1. Rinse the sensors and calibration cup once with water. Step 2. Rinse the sensors and calibration cup with conductivity solution. In this case, we will use 1413 microsiemens per centimeter at 25 degrees Celsius. Repeat this last step 2 more times for a total number of 3 rinses with conductivity solution. Step 3. Screw the calibration cup onto the inverted sonde. Step 4. Fill the calibration cup with conductivity standard, again using 1413 microsiemens per centimeter, or 1.413 millisiemens per centimeter, so that the conductivity probe and the temperature sensor are completely submersed in the calibration solution. Rotate the sonde to ensure that there are no air bubbles inside any part of the conductivity sensor. Wait a minute before moving to the next step to allow the temperature to stabilize. Step 5. From the Sonde menu, select Calibrate and press Enter. Step 6. Select Conductivity and press Enter. Step 7. Select SP-Cond, Specific Conductance, and press Enter. Step 8. Use the keypad to enter the known concentration of the conductivity standard at 25 degrees Celsius in millisiemens per centimeter. In this case, our standard is 1.413 millisiemens per centimeter at 25 degrees Celsius. Press Enter. When readings are stable, record the pre-calibration value of conductivity in microsiemens per centimeter. Step 10. Highlight Calibrate. Once the temperature reading is stable and the conductivity reading is stable, press Enter. Step 11. Record the post-calibration conductivity value in microsiemens per centimeter on the calibration worksheet. Also record the temperature value in degrees Celsius from the sonde on the calibration worksheet. Step 12. Record the conductivity cell constant on the calibration worksheet. First, press Enter to continue, and Escape to return to the main menu. Look for the conductivity cal constant under Advanced, Enter, Cal constants, Enter. The conductivity cal constant should fall between 4.55 and 5.45 and should not vary from the historical value more than 0.1. You can look back at previous calibration sheets to determine the historical value. If the value doesn't meet these criteria, the calibration standard may be off. You can try another bottle of calibration standard. If the constant is still off, it's best not to deploy this sensor and contact ENR for support. Step 13. Turn the sonde back to its normal orientation. Remove the calibration cup . And add a thermometer to the solution. Allow sufficient time for the readings to stabilize. Record the value from the thermometer in the box for temperature standard on the calibration worksheet. Step 14. Empty the calibration cup. And rinse all the sensors and the cup thoroughly with deionized water before calibrating the next parameter. Conductivity calibration is now complete. pH calibration. pH requires a 2-point calibration. Before pH calibration, make sure that pH in millivolts is turned on under the sonde menu, Report. Enter. pH millivolts is turned on. Step 1. Rinse the sensors and calibration cup once with deionized water. Step 2. Rinse the sensors and calibration cup with pH 7 solution. Repeat this step 2 more times for a total of 3 rinses with pH 7 solution. Step 3. With the sonde inverted, fill the calibration cup with pH 7 solution to immerse the pH bulb and the temperature sensor on the conductivity probe. Step 4. From the sonde menu, select Calibrate and press Enter. Step 5. Select YSI pH and press Enter. Step 6. Select 2-point, press Enter. Step 7. Input the value of the pH solution at your calibration temperature. You can find this on the table on the standard bottle. At the prompt, enter the value and press Enter. In this case, we are calibrating at 20 degrees Celsius. The input value will therefore be 7.02. Press Enter. The values of all the sensors will appear on the screen and change as they stabilize. Step 8. Record the pre-calibration reading in pH units on the calibration sheet. Step 9. If the pH reading is not changing significantly, press Enter, and the calibration will be accepted. Step 10. Record the post-calibration reading in pH units on your calibration sheet. Also record the post-calibration pH millivolts on the calibration sheet. The pH millivolts value should be between -50 millivolts and +50 millivolts. Press Enter to continue. Step 11. Return the sonde to the proper orientation. Empty the calibration cup. Rinse the sensors and calibration cup once with water. Step 12. Rinse the sensors and calibration cup with pH 10 solution. Repeat this step 2 more times for a total of 3 rinses with pH 10 solution. Step 13. With the sonde inverted, fill the calibration cup with pH 10 solution to immerse the pH bulb and the temperature sensor. Step 14. Input the value of the pH 10 solution at your calibration temperature. You can find this on the table on the standard bottle. In this case, we are calibrating at 20 degrees Celsius. The input value will therefore be 10.06. Press Enter. The values of all the sensors will appear on the screen and change as they stabilize. Step 15. Record the pre-calibration reading in pH units. Step 16. When the pH reading is stable, press Enter. The calibration will be accepted. Step 17. Record the post-calibration pH reading in pH units and the post-calibration pH millivolts on the calibration sheet. The pH millivolts value should be between 165 millivolts and 180 millivolts below the pH 7 millivolt reading. If the difference is less than 165 millivolts, the reference solution inside the pH probe is likely too old, and it's best not to deploy this probe. The lifespan of reference solution inside the pH sensor is only 1.5 to 2 years. Press Enter to continue. Step 18. Return the sonde to its proper orientation. Empty the calibration cup. And rinse the sensors and calibration cup with water. pH calibration is now complete. Calibration of oxidation reduction potential, or ORP. Calibrate ORP after calibrating pH. Step 1. Prepare the Zobel calibration solution according to the instructions on the bottle. Open the bottle and add 125 ml of deionized water to the dry powder. The solution has a half-shelf life of 6 months once mixed. Step 2. Rinse the sensors and calibration cup with deionized water and then some of the Zobel solution. We have already completed these steps. Step 3. Pour the Zobel solution into the calibration cup and immerse the pH and ORP sensor and the temperature sensor in the solution. Step 4. From the Sonde menu, select Calibrate and press Enter. Step 5. Select ISE2 ORP and press Enter. Step 6. Enter the value of the ORP solution in millivolts at the calibration temperature. See the table in the instruction manual. For example, if we are calibrating at 20 degrees C, the value to enter will be 237.5 millivolts. And press Enter. Step 7. Monitor the stabilization of the ORP and temperature readings. Once they are stable for approximately 30 seconds, record the pre-calibration ORP value in millivolts on the calibration worksheet. If the probe is functioning within specifications, the ORP reading should be within the range of 221 to 241 millivolts at normal ambient temperature. Step 8. Press Enter to confirm the calibration and record the post-calibration ORP value in millivolts on the calibration worksheet. Step 9. Press Enter to continue and Escape to return to the main menu. Step 10. Reorient the sonde, empty the calibration cup, and rinse the sensors and cup with deionized water. Calibration of ORP is now complete. Chlorophyll calibration. Step 1. Ensure that the sensors and cup have been rinsed thoroughly with DI water. Submerge the chlorophyll sensor in deionized water. Step 2. From the Sonde menu, select Calibrate and press Enter. Step 3. Select Optic C Chlorophyll and press Enter. Step 4. Select Chlorophyll RFU 0 and press Enter. Step 5. Input the Chlorophyll RFU value of 0 at the prompt and press Enter. Step 6. When the readings have stabilized, record the pre-calibration chlorophyll reading on the calibration sheet. Press Enter to confirm the calibration and zero the sensor. Step 7. Record the post-calibration chlorophyll reading on the calibration sheet. Press Enter to continue and Escape to return to the main menu. Step 8. Grab samples must be collected near the sonde at certain times during deployment and the chlorophyll content determined in the lab. Note the exact dates and times that these samples are collected. These samples will allow the relative readings collected by the sonde to be expressed as real chlorophyll concentrations. Turbidity calibration. Turbidity requires a 2-point calibration. Turbidity must be calibrated with the sonde in the upright position. Step 1. Ensure that the sensors and surroundings have been cleaned and are free of debris from past deployments. Any solid particles will contaminate the standards during the calibration and cause the instrument to collect incorrect data. Step 2. If the 0 NTU standard is in a jar with a wide enough mouth, lower the sensors into it so that only a few millimeters of turbidity sensor are submerged. Note, this jar should not be plastic. It should be clear or dark glass, and it must be placed on something black. If the 0 NTU standard is not in a usable jar, pour some of it very slowly, avoiding bubbles, into the calibration cup so that the end of the turbidity sensor is submerged. Engage only one thread when screwing the calibration cup onto the sonde to keep the sensor face as far away as possible from the calibration cup bottom. The sensor cup itself is a source of interference. Step 3. Reduce the lighting in the room. We're not going to do that here so that we can keep filming, but you should lower the lights. Wrap a black plastic bag around the cup. Step 4. From the Sonde menu, select Calibrate and press Enter. Step 5. Select Optic T Turbidity and press Enter. Step 6. Select 2 point. Press Enter. Step 7. Input the value 0 at the prompt and press Enter. The screen will display readings. Step 8. Activate the sensor wiper 1 to 2 times by pressing 3 Clean Optics. Step 9. When the readings have stabilized, record the pre-calibration turbidity reading for 0 NTU on the calibration worksheet. Step 10. Press Enter to confirm the first calibration and record the post-cal value for 0 NTU on the calibration worksheet. Step 11. Press Enter to continue. Step 9. When the readings have stabilized, record the pre-calibration turbidity reading for 0 NTU on the calibration worksheet. Step 10. Highlight Calibrate and press Enter to confirm the first calibration. Record the post-calibration value for 0 NTU on the calibration worksheet. Step 11. Press Enter to continue. Step 12. Empty the cup and rinse the cup and sensors with DI water. Dry both the calibration cup and the turbidity sensor. Compressed air is handy for this step. Step 12. Empty the cup and rinse with DI water. Dry both the calibration cup and the turbidity sensor. Compressed air is handy for this step. Step 13. If the 0 NTU standard is in a jar with a wide enough mouth, lower the sensors into it so that only a few millimeters of the turbidity sensor are submerged. Note, this jar should not be plastic. It should be clear or dark glass, and it must be placed on something black. If the 100 NTU is not in a usable jar, pour some of it very slowly, avoiding bubbles, into the calibration cup so that the end of the turbidity sensor is submerged. Step 14. Reduce lighting in the room and wrap a black bag around the calibration cup or jar. Step 15. Input the value 100 at the prompt and press Enter. The screen will display readings. Step 16. Activate the sensor wiper 1 to 2 times by pressing Clean Optics. Step 17. When the readings have stabilized, record the pre-calibration turbidity reading for 100 NTU on the calibration worksheet. Step 18. Highlight Calibrate and press Enter to confirm the second calibration. Record the post-calibration value for 100 NTU on the calibration worksheet. Press Enter to continue, and Escape to return to the main menu. Step 19. Empty the cup and rinse sensors and cup with deionized water. Turbidity is now calibrated.